Hello, welcome back. In this segment, I will talk about the conditional move statement. Okay, let's take an example. Move 0 to EX, that means at this moment EX is 0. Move 1 to EDX, that means EDX will be 1. Test instruction will do a bitwise undo between EDX and EDX. It will not change the destination register. It may enable some flags depending on the outcome of the test. So in this case, EDX is 1. 1 and 1 will be 1. So we don't expect the 0 flag to be turned on. Therefore, conditional move will go ahead and transfer the EDX content to EAX, right? At this moment, we expect EAX to have the value 1. Let's check that. Just compiling the code to produce a binary that we can load it into GDB and study it. Okay, so I finished my compilation. Now I will go into GDB. You should see the same code that I shown on the other screen. Okay, so we have conditional move. Let's put a breakpoint after the test instruction is done. Run it, print the flags. Flag only inter flag is turned on, which we don't care so much. Okay, so 0 flag is not turned on. Therefore, we expect EDX to be transferred to EAX. Okay, let's first print the value of current EDX and EAX. EAX is 0, EDX is 1. And if you move the value of EDX to EAX, we expect EAX to have the value 1. Since 0 flag is not turned on, the conditional move will go ahead and work. Okay, so let's look at the value of EAX now. Yeah, EAX is now 1 because we just finished the move statement. Okay, all right. So this is how conditional move works. It checks the status using the flags, right? The conditional codes. In this case, we said conditional move not equal. That means if the 0 flag is not turned on, it will move the value from EAX to EAX. Okay. Now let's change a little bit and study a little bit more detail. Let's go here. Make my EDX to be 0. Well, in this case, let's say EAX is 1 and EDX is 0. In this case, the test should result in a 0 flag turned on. So this statement won't work. Okay, EDX transferring to EAX won't work. We can check that. So I argue that the conditional move statement will not work. We can put a breakpoint and study that. Okay. Let's print the flags. The 0 flag is turned on. Okay. We don't care about parity and interrupt flag so much. The 0 flag is turned on because the bitwise AND of EDX with EDX is 0 because EDX is 0 here. Therefore, the conditional move won't work. So therefore, EX will still be 1 after the conditional move statement is done. Let's check that. Yeah, it is still 1 because we didn't execute this move statement. Okay, so far, not that exciting. But let's look at one more change. Let me now do a memory reference here. Okay. So we expect now this to not work because EDX is still 0 and test will result in 0. So we would think that conditional move will not even work because the 0 flag is turned on. Okay. This should only work if the 0 flag is not turned on, right? But let's see what happens in this case. If you compile and run. If you compile and run this one, it won't work because it has the flags turned on. Therefore, I will now show you how to do this. If I now compile and run, it will just crash. It crashed because we can now even look at the instruction that led to the crash. Okay, let's look at the instruction. You see here, the conditional move instruction was the reason for the crash because EDX is 0. Okay, but then you may wonder, if you look at the assembly again, right? EDX is 0. We know for sure EDX is 0. We can even print it. EDX is 0. Therefore, flags, if you look at the flags, the 0 flag will be turned on. It is turned on. Then how come conditional move was going ahead and executing when it is not equal to 0? That's what we said here. Conditional move not equal to 0 is allowed to do this transfer. But here is 0 flag turned on. Okay. The reason why the program crashed is that conditional move will go ahead and do a memory referencing. Okay, it will not do the transfer. Okay, this is much more low level detail than I can go here. Conditional move will go ahead and do a memory referencing. At the time memory referencing was done, EDX is actually 0, right? Therefore, the program crashed. Okay, so conditional move, you have to be careful. Conditional move will do memory referencing independent of the status of the flag. Okay, and if the memory referencing is not pointing to a valid address, you may have a problem. Okay, let's go ahead and change that 0 to something else and see what happens in that case. Let's see whether, if I hard code this for a moment, yeah, what happens in that case. Instead of 0 in the EDX, right, let's put something here. I don't know whether this is going to be a meaningful address. We will compile and see. You can check it and then change the address again if needed. Okay, the address seems to be valid. Okay, now the question is, what will be the value in EAX? In this case, EDX is a non-zero number, right? So it's going to do a memory referencing of wherever EDX is pointing to and transfer it into EAX. Okay, let's do that now. Let's do here, copy and paste, run. Okay, now we print the flags. The 0 flag won't be turned on because EDX is non-zero. Okay, therefore conditional move will refer the content of EDX rather, and transfer it to EAX. Let's look at what is there in EDX. EDX has this address, which has basically machine code. Okay, let me. So as you can see, it's pointing to machine code. This is the machine code. We can actually even do one more thing. We can disassemble this way, and the address is, this is the address, and that address has B801000. So we can see after the conditional move statement is what is the value of EAX. Okay, we see EAX has B801. Yeah, here is B8, and that's the 01 part. Okay, so we can see that conditional move is able to transfer data if you have memory referencing, right? This is the memory referencing part. And the most interesting thing is, if this pointer is not valid, conditional move will still go ahead and do a memory referencing. That's why you want to be careful. Let me show you what I mean more precisely here. Let's go back to the original program and just put some ABCD here, right? Which is very likely not a valid address, right? Let's say A, B, C, D, E, F. Okay, some address, we don't care. Okay, this is an invalid address. And we will compile this outside and run it. It should crash. Yeah, it crashed. What is the reason for crash? We can look at the current instruction that led to a crash. This is the instruction that led to the crash, because if you look at the EDX is invalid memory address. It doesn't exist. Okay, let's go back here, change the code, make the EDX to be 0. Okay, now test will have 0 flag turned on. Nevertheless, it was going and doing a memory referencing. Okay, so if I just compile this and run it, it should crash. This, and I ran, it crashed. And if I look at the EIP. If I look at the EDX is still 0, but it was referring the memory, even though the 0 flag is turned on after the test instruction is done. Okay, we can even print the flags. Yeah, you can see the 0 flag is turned on, but memory referencing will anyway happen because of the way conditional move statements actually work. Okay, so you want to be careful not to refer memory if the memory is null or invalid. Okay, that's why I wanted to show you this demo. Thank you.